Good morning, Yuzhi. I'm extremely grateful for your generosity. I will give a brief description about my project code. I created a class graph with two attributes, the mat and the dictionary, which representing the adjacency matrix of a graph and a list of age in a dictionary type in Python language. And for this function, random adjacency matrix. With the given input, the number of vertices and the number of edges, it will return the adjacency matrix randomly. And for this row, it will calculate the maximum age of a graph. And when the edges are rare, I use this code to ensure that the graph is connected. Because for each number of vertices that are input, I will create three pairs of vertices and edges, so I can do the comparison to observe the change between vertices and the edge, number of edges. And this function is used to turn a matrix to a dictionary type. And because I use the dictionary type in Bellman-Ford algorithm. And this function BFS, firstly, it will gain the matrix from the class, and I create a list called queue. You add the first node into the queue and begin and again in the loop. I will pop it and go into this adjacency list and to check every adjacent vertex that this node is connected and add them to the queue until, and I repeat this again and again until there's no vertices in the queue, and I will return the cost of this algorithm. And this function is used to stimulate Dijkstra algorithm. For the initialization, I will turn the code between the start to any other node to 0 and else to infinite, and the parent of every node will be -1. Then I will get in the loop. I also create a list visited to mark the determined node if it is visited or not. I will search the minimum cost from the cost list and mark this node and add it into the T list. When every node of this graph is added into the T list, the algorithm will be done. And I will begin from the selected node, traversal every edge of this node to calculate the minimum distance. Then I will update the distance and the parent. This function returns the cost of this algorithm. This function will implement Bellman-Ford algorithm. I will initialize the distance between the source node, which is start, to any other node in this graph to infinite, and the parent node also. And I will do many times relaxing. Relaxing is that I will check if the distance between the from node and to the to node and plus the distance from this edge will be, if it's larger or smaller than the current cost of the to node. If it is smaller, I will update the distance of the to node and also the parent of it to the from node. And this function returns the cost in microseconds also. After describing all the functions above, I will begin to introduce my main function. Firstly, I will input the number of vertices in order as it is in a node list. There are 50 nodes, 100 nodes, and for every number of vertex, I will create a pair. I will create 3 pairs of edges, so I can do the comparison between the change of vertices and the edges. These two rows code I is added just now, but I run this code 20 minutes before, so it did not display on the screen. You can see that every pair of the node and edge, and I create a data frame. It's a structure. It's a data structure, and it will record the cost of every 3 algorithm of every pair of vertices and the edge. And you can see the result in the file I submitted. It's in a CSV format. Like this, the first row is BFS, and the second row will be the cost of Digistrat, and the third row will be Bellman for cost. They are all in the unit of seconds. Thank you very much.